Hey guys, how's it going? Today I'm gonna show you how to create a snap to grid building placement for mobile devices in Unity. I tried to find tutorials online and it seems that there are no tutorials of that sort, so I thought I'm gonna show you guys how to do it. This is how it's gonna look like at the end. So we have a building, you click on it and you can drag it around and it snaps to the grids, as you can see. Okay, so let's go to Unity. Okay, here we have a simple scene that I created. You can create anything you want. So I have a main camera, simple main camera, directional light, and a plane that has ground material on it with grass ground material. I also have a prefab, which is just a building. So you can have anything you want here, but I have this one. And we need 3 scripts. So you can just create these 3 scripts right now. And we can go to the first one. Okay, so for this one we need 2 variables. The first one is the list of all the game objects. Oops. The second one is the reference to the script, the building placement script. Okay. So now we can, in the start, we can just do building placement equals good. We get the reference of the script. Placement. Then we create a function here, which is public void pick number. And here we just do building placement, building placement. That's set item buildings. So here we're just gonna call a function set item in the building placement script. And now we can go into building placement. Okay, so in this script, first we're gonna add a function set item, public void set item, game object building. This is the game object that's gonna be passed in here from this. So in here, first we have to instantiate the building. So current, so okay, first we can put this variable here, private transform current building, and then from here we can create current building equals instantiate building new vector 3 0 0 0. I'm gonna explain everything I'm doing here in a second. Identity dot transform. Okay, so whenever this is called, we instantiate the building that's passed from here. After that, it's going to be created at the position 0 0 0 on the in the world here. 0 means 0 on X, 0 on Y, and 0 on Z. And then here, this is just so it doesn't rotate. It stays the same as the actual model. That's how it's instantiated. So after that, we can also get the camera and get the camera so it's gonna follow the building around. Get component camera transform position equals new vector 3 0 get component camera dot transform dot position dot y, and then -30. Okay, so here the camera is going to be created at 0 on the x-axis. Then this is the height of the camera right now, because we can see here, if you click on the camera, the y position is 60. That's how high the camera is from the ground, as you can see here. And then -30 is just for the camera to be centered. The building is centered on the screen. Okay. Now we can create the actual script where it's gonna follow your finger, and then the building is gonna follow your finger, and the camera is gonna follow the building. So first we check if there is any input, if anyone touched the screen, pretty much. So greater than 0, then this is a switch touch face, and then here this should be small. Here we do touch, we get that touch if there is any. Get touch 0. So this switch function is always here if you want to try to do cases. And for cases we're gonna have here, we're gonna have a case 1 is gonna be touch face dot begun. Another one is gonna be case touch face dot moved, and then the third one is gonna be case touch face dot ended break. Okay, so now we get the touch position. So we store the position of the touch in vector m, and then now we do m equals vector 3 . Okay, so for this, all this does is just takes the position of the touch x, position of the touch y, and the transform position y is just how high the camera is. This is just, it's going to be always the same. So now we need a new vector to translate the position of the touch into the position in the actual world. vector 3 position equals format camera, and then we just do screen to world point. Yeah. So all this line does is it creates a new vector 3, which is called position, and it translates this vector into the actual coordinates in the world. Okay, now we can just call this like that. What's wrong with this? Let's see. Okay, never mind. All fine. Okay. So now we do the current building dot position is gonna equal to the new vector 3 x over 2 0 y times 5. Okay, here we could just do without the division by 2 or without multiplication by 5. All this does is just it makes the movement slower, because if you remove this, it's going to be really fast. It's going to move faster than your finger. So we just add this here. So all this line does is just translates the current building position to the position of your touch in the world. And then for the camera to follow your finger, you have to do pretty much the same thing. So we do camera dot transform dot position equals new vector 3 vector 3, and then we just copy this here, but we change this one to transform the position y, because we have to keep the height of the camera, otherwise it's going to be at the 0 position. Okay, now we have to go to the other script, which is snap to grid, and here this is a pretty simple script. So here we need two variables, public float grid equals 6.65 f float x f. Okay, all this does here, this is 6.65. that's just because my plane is 40 by 40 and the material on it is 60 by 60, but it depends on your current size of the grid. So for me it's 6.65, but the way you get this one is you divide 40 by 60, and then you add that value times 10 to this value. So okay, I'm gonna show you how. So let's say the length of the plane is 40, so we divide it by 60, so we get approximately 0.6. So after that we do 60 plus 6. It's because this is multiplied by 10. And then all of this divided by 10. The whole thing. So that's how it's done. And this is just the starting position of the grid. 0, 0. Okay, so now we go into update. If grid is greater than 0, this is just to check if the grid is actually greater than 0, then we have to do something. So that we do float this. Okay, I'm gonna explain. All this does is just gets the reciprocal of the grid. And we needed to calculate the distance of each square from the other square. So it is snapped to each square when it is rounded here. I'm gonna show you how to do it. So x equals math f round transform position dot x times reciprocal grid, and then we divide this whole thing by reciprocal grid again. So we copy this, do it for y, the exact same thing, just change this to y, and then transform the position equals vector 3 x so y, this is gonna place the building at the rounded position in the x and y coordinates. So this is snap to grid, and for the coding part we're pretty much done now. We just have to assign everything here. So here we have a camera, and for the main camera we need these two scripts, which is building manager and building placement. Okay, now we assign this building here. This is going to be the building that's going to be instantiated. Then for building placement, we don't need anything else here. Okay. And now we go into the lumber mill. We have to put snap to grid. That's going to be snapping it to the grid. And then if you want to create this button here, we can create a button, and then on click event is just going to be the main camera, and then from the main camera we take the building manager and pick buildings, and we take this zeroth building, which is the first one. So this should all be working, and we can just enlarge this button. So this should be it. Let's see, let's try this. But the main problem with this is that it's not gonna work in this editor because it doesn't recognize the touch, because this is not an Android. But the placement should still work. Okay. So it works, but it's not gonna move. You need an Android emulator or something like this for it to move. Okay, So that is it for this tutorial. If you enjoyed, you can subscribe to the channel for more tutorials and leave a like. If you have any questions, leave them in comments down below and I'll do my best to respond. Have a good day.